All right, it's great to be here. As David said, it's now well into the lunch hour, and we thought instead of letting you eat food, we would talk about food. But it's our goal to get you all salivating so that you'll truly enjoy the food once we release you to eat it. I think as David said also, that the application of biotechnology to food really is so interesting because we're now talking about something that every person and every animal, but billions of people on the planet do every single day. And so this is something that really could impact everybody. And I think there's such a wide spectrum of ways that they could be impacted. We've got kind of the Willy Wonka types on this panel that are going to talk about creating entirely new types of flavors, and I love this word mouthfeels and textures, but ways to experience food. And then there's the whole other side of the spectrum, which is how do we do things more efficiently, better, and do more with less. So we've got a wonderful panel here that I'd love to quickly introduce, and then we'll jump into some of the exciting things that they're working on. To my left is Andras Forgax. He's the co-founder of Modern Meadow, which is a company that's growing individual animal cells, knitting them together into products like meat and leather without the need for any live animals. And so their technology, though, it doesn't just enable reproductions of the meat, but it lets you do all kinds of interesting things with them, and they're working with world-renowned chefs to figure out what those things will be. Jim Flatt is here. He's the president of Genovia Bio. It's a division of synthetic genomics where he works with Craig Venter. He's working to design algae to produce the fuels and the foods of the future. So making food ingredients like proteins and oils, and doing it this way with algae is much more dramatically more efficient, and we'll talk a little bit about that. And the cool thing is that these proteins and oils can actually be engineered so they improve your health. So they're more nutritious than what you would get otherwise. Dr. Reshma Shetty is third down the line here. She's the co-founder of Ginkgo Bioworks. She's engineering microorganisms that use fermentation to create cultured ingredients that can replace extracted ingredients. We'll find out more about what all of that means. But I love that her technology enables these flavorists, which is such a great job title. I'd love to be a flavorist, to custom design the tastes and the flavors and the odors that will get put into the products that you eat. So we'll hear more about that. And then Randy Komisar at the end down there. He's a real Renaissance man. He's got his fingers in a lot of different pies. He worked with visionary George Lucas as the CEO of LucasArts early in his career, back when they were releasing some of my favorite video games, like Day of the Tentacle and Rebel Assault. So nice work, Randy. But now he's a partner at Kleiner Perkins, and he works on what he calls meaty problems, pun intended. And by meaty problems, I think he means big, important problems that really matter. And one of those is the food supply and kind of food technologies. And so thinking about how do we grow, distribute, and eat foods. Just as a quick side note, many of our panelists have pretty adventurous palates. I was asking them what some of the crazy foods they've tried are. Both Jim and Randy have experimented with eating snakes during their travels in Asia. Andres issued me a challenge to find a food category that he didn't like, so I'm still trying to do that. And Reshma actually follows her heart with their research and enjoys a fermented crepe called dosa. So they've all got pretty interesting food tastes. So with that, we'd love to dive into what each of you are doing with respect to food. Andres, I think I might start with you. What is the advantage of removing the live animal from the equation?
Sure. So just by way of context, at Modern Meadow we have a food program and we have a materials program. We're developing a way to grow leather and leather-like materials without having to slaughter animals, and we're also developing a way of growing meat and umami savory products without having to slaughter animals. Now, that said, the animal is not completely absent from the equation because you need to source the cells from somewhere. So in the case of our food program, we take cells from the very best animals you could possibly imagine, the healthiest animals. And by the way, the process does not need to kill the animal. So this is a great way of let's say, going to the prize-winning heifer, the most delicious Angus cow, taking cells from it. The cow can continue to live a very happy life.
So you take a biopsy, basically.
Exactly. You take a biopsy, and then we expand those cells in very large quantities. And so we're effectively becoming the world's most efficient mammalian cell factory. Now the advantage, and in the materials program, we actually may not ever need to go back to the animal because we can do things at the cellular level. That means we never have to go back to the animal again. But the advantage of doing that is that animals take a lot of space. If you put all the livestock industry all together, it's using about a third of all available land, ice-free land in the world, directly or indirectly, for grazing or for feed crops. They consume a lot of water, and they contribute to a lot of greenhouse gas emissions. So by taking animals out of the equation and just relying on a much smaller donor pool of animals, the process is a lot less resource intensive. And you also have a lot more control over the process. So animals have a fairly inefficient feed conversion ratio. It takes about 10 pounds of grain for a cow to produce a pound of body weight, and you only consume or effectively use 1/3 of that mass for food. So,
and ridiculous amounts of water, right?
Exactly. So the process is a lot more efficient. You have a lot more control over that process, and then you can actually get into interesting artisanal questions like controlling the terroir of the protein that you're growing. You can grow it in broth that has different aspects to it, so you can actually control the protein content, the type of protein, the flavor of the cells that you're growing. So it gives you a lot more control. It's a cleaner process. It's a more transparent process. It's a process, by the way, that's quite inviting. You can run it and make it look a lot like a brewery. So eventually you can go and visit a facility and see the process soup to nuts, which is not something that you can do currently with the traditional meat industry.
And what does it taste like?
So far we've been actually going after products that are not perfectly biomimetic. It's a strong design philosophy we have. Our goal is not to create the I can't believe this is not a slaughtered hamburger or I can't believe this is not a slaughtered steak. If you're coming up with a fundamentally new process, you owe it to yourself to be authentic and to come up with products that ring true to this new ingredient. So one of the things we've done to illustrate this is we've created a crunchy beef jerky product called steak chips. Now again, we're not committed to commercializing this, but it illustrates this idea that if you fundamentally redesign animal protein, you have a much broader design space. And steak chips are a snack food product with 70% protein content. They're really delicious, very, very healthy, very low fat, and they're very savory, very umami. So it builds on this growing trend of umami savory in the market.
And it's delicious.
It's delicious. It comes in a barbecue flavor and teriyaki flavor. And now we're working, as you said, with high-end chefs to come up with all kinds of other form factors. So I won't say much about that at this point, but we're going to come up with products that are, again, building on the savory growth in savory, growth in fermentation, and they're not what you might think. They're not a mass of meat in the middle of your plate.
Nice. And so, Jim, I'm curious. I think we all have a sense of what a farm looks like or a cornfield looks like. I'm curious to know, what does an algae farm look and feel and smell like?
Sure. Well, maybe just to step back. First off, how many are familiar with algae or know what the algae are? Okay, so maybe 2/3. So algae are simple plant cells, and they actually come in two versions. What we know most are those that use light, and there are also some that can use organics or sugars and have a lot of similarities with yeast. So when we look at producing algae-based food and feed ingredients, when we go out onto a farm, it's sort of a hybrid between a baker's yeast type production factory and a big lake. And so when you enter the facility, you'll actually see sort of starter cultures that most of which are green in flask, and you can think about those as your baker's yeast. That's your starting inoculum, and your goal then is to actually grow that out, to just propagate those cells so you can do it at larger and larger scale. So those cells will then go into a reactor that looks like a sort of glass tube, if you can think about a big serpentine glass tube, and that allows you to get a relatively pure culture, which can then be introduced into different production systems. But the most common are, sort of acre-size open raceway ponds. So these are things that are either use pumps or paddle wheels, but you'll see these acres of what looks to be a lake, but is really a lake filled with algae cells.
Delicious algae.
That's right. They can then be harvested and processed much in the way you would process yeast.
And you're actually designing the DNA of these algae, is that right?
Yeah. So what gets us excited about algae is, we see the opportunity to make this the next major crop in the next 10 to 20 years. And the reason, that's exciting is, first off, it can be produced on marginal lands, with a minimum amount or actually no requirement for fresh water. That's a big plus when we look at all of the sustainability issues and constraints. Secondly, it can also produce a wide range of fairly healthy whole foods as well as nutrients. So algae are very rich sources of protein and micronutrients. So those are the reasons, to get excited about algae. What we do is to try and take our knowledge of living systems and cells and actually develop whole algae that will be, in fact, tailored for certain purposes, whether it is to produce complete sources of protein, which is one of the ingredients that we have in development with a major partner, or to improve its efficiency so that we can actually produce more algae per unit of land, which will improve the economics. And so it's really that being able to alter the software of the algae, the DNA, that gives us the ability to make it more economical and to realize the potential to produce these healthy ingredients.
And how difficult of a design problem is it? If you say, I want this to work in brackish water or in salt water, is there a gene for that?
Yeah, so unfortunately it's not easy. In general, life is complicated, as we know, and so, there are many traits that actually confer, for example, the ability to grow in higher salt systems. So it's not just one gene, and that's where our knowledge is imperfect. But what's nice is we can often identify genes that have an impact, 10, 20%, even 100% kind of impact. So while they're not the complete solution, they get us far enough on the curve that it makes a difference. But, still, we don't know, the function of more than half those genes in any of the algae we work with. And so it's always going to be imprecise, and we're working with imperfect knowledge. And always room for improvement. Yeah. And it tastes delicious also. Pretty. Tastes great. Less filling, but it's no. Actually, we're working, and this is where the partnerships are so important with those in the chain, the supply chain. We work on actually making these quite benign. So we have some algal protein concentrates that, if handed to you, would look like a nice tan powder with virtually no aroma. And we're working very hard to have as little flavor impact as possible. Interesting. Yeah. So on the complete opposite side of the spectrum then, Reshma, can you tell us a little bit about the advantages of engineered fermentation? Yeah, so the first thing to know is that fermentation is basically a way of doing cooking, but using microbes, right, instead of heat. And humans have had a long history of eating and consuming fermented foods and beverages, right? The oldest fermented wines were found at on the archaeological record, there's, wine dating back to China like 9,000 years ago. Basically all of the kind of best foods and beverages are made via fermentation. Beer, wine, chocolate, some coffees, cheese, bread. If I had to do without microbes for making my foods, I'd be pretty miserable. And
And it turns out that a lot of the flavor and the aroma profile of these food and beverages comes from the microbes, right? And so what's interesting now is that because we've had kind of these new technologies in genomics and sequencing and synthetic biology, we can think about starting to play with the microbes themselves and what impact they have on the foods and the beverages. And we can actually design the microbes to produce new flavors or new aromas that they couldn't produce before, right? And so one of the things we're really excited about is this idea that we can actually couple biological design, how we design these microbes, to kind of design of new aroma profiles or new flavor profiles in the foods and beverages that we're consuming. And so we call these, cultured products, cultured ingredients. And we're just really, fascinated by this idea that you can design the biology, but yet have an impact on the human experience of, how humans perceive the foods and beverages that they're consuming. And so we're really excited about the potential there.
And can you describe a little bit about what it's like to work with flavorists? I mean, I'm presuming they're not that scientifically savvy. So how do you translate what they want and what they're asking for in their vocabulary into?
I think whenever you bring two new fields together that haven't been together before, there's a lot of learning and education and cross-fertilization that happens. And so, there are folks who are just, have a long careers and history who think about, what is the impact of the particular blend of molecules on, the perception, both from an odor point of view, but also the feel in your mouth and are there aftertastes and things like that. And so I think there's on both sides a very deep, knowledge but enthusiasm for design, and so it's just really great to kind of bring these two areas that haven't been talking so much together, and I think there's a lot of opportunities there.
Great. Then, Randy, from an investor's perspective, when you look at food, huge opportunity. To you, what are the most important, the meatiest food-related problems that you see that have interesting technology solutions out there?
I think the panelists are doing incredibly impressive stuff, and I think what's interesting now is to see the convergence of all of these ideas plus others around real market opportunities. So, I have to time my interests around when the market's ripe enough to actually deliver great returns around these investments. And I believe it is very ripe right now. If you look at the food issues as a reflection of the population issues on a global basis, we are at the precipice of very, very big changes, both as our own society, but also as a global population and global society. And so what I'm seeing is, on a soup to nuts basis, a variety of different solutions that look like the sort of assortment of solutions we saw when we looked at the PC or storage or big data. We're seeing new materials. You've heard a lot about new materials here today. We're an investor in a company called Beyond Meat, doing plant protein substitutes for meat protein, and the marketplace is now open to these things. They're very interested in these new foods. They're very interested in the nutrition they deliver, and they're looking for alternatives. We're an investor in a company I would call it sort of in the traditional hybrid produce business called Volo Agri. It's in the plant genetics business. It is developing plant genetics on a global basis for mass redistribution as well as for new forms of farming. For instance, under glass and in protected farming, which I think is the future of farming. And so we begin to see how resources are recirculated in those environments, how much more control we have over yield and quality and food safety in those environments, and we're developing genomics specifically for those new environments. I'm an investor in our company that was still stealth, but is trying to look at the distribution chain from farm to table and figure out how to take wastage out of that chain while delivering great nutrition and attractive foods at the other end. And it's a device, it's a connected device, it's Internet of Things, it's information, it's farmers, it's all of those things together in one process that delivers to customer a really satisfying value proposition around something they like, which is food. We're investors in big data. Farmers Business Network is a company one of my partners went off to found that I'm on the board of, trying to create a collective database for farmers that for the first time gives them a at least equal playing field with vendors and with the purchasers of their products around information. They've never had it before. And the opportunity now with drones and sensors in the field to have real-time data around plants, regions, soil, not just things like weather, which is the first shot at this, which is what Climate Corp did. This is now real and present and global. So I'm seeing incredible opportunities out there, and I'm super excited about them. Andreas has made me very self-conscious about my boots. But I will.
I think Andreas will work on that. He'll give you some nice full leather.
We're taking pre-orders.
And they're tasty and delicious.
They're tasty.
And are there any big unmet needs that you see where you haven't seen a great technology solution yet? Where you say, boy, I wish there was something out there, but I haven't seen it yet.
Well, I mean, clearly, I think there's going to be more interesting work done on what I would call sort of the production side of food. But frankly, what's interests me more, because it's such low-hanging fruit, so to speak, is the distribution side. I believe there's enough food on the planet right now to feed everybody well. It is not distributed well, and a lot of it is wasted. And so the question of distribution, which arises in food, but I think in many other aspects of our lives today, as we begin to look at what I think is a skewed distribution that creates scarcity where there isn't scarcity. In the food business, I think it is very, very prevalent. The amount of wastage between farm and grocer is oftentimes above 20%. The amount of wastage between the grocer and the consumer's ultimate consumption can actually be greater than that. And so beginning to use data, information, new supply chain technologies and tools to make customers and consumers smarter about what they consume, and to allow farmers through distribution to be more effective in the supply chain. This can make a big difference in the amount of food that's available and how fairly it's distributed in our society.
Yeah, Randy makes a very good point that right here on this panel you've got three innovators on the supply side. But frankly, to solve the big challenges that we have, we need not only a diversity of solutions on the supply side, we also need better demand management, and we need innovations in distribution. However, what's interesting is that innovation on the supply side can co-evolve with innovations in distribution. So as you come up with an entirely new way of making your products, there's entirely new ways of bringing those products to market.
Well, I think information technology allows us to close that loop in a way we couldn't do even 5 years ago.
Exactly. I mean, for example, what we do is we're effectively brewing meat. We're brewing leather. And that allows you to do animal production in an urban environment. Right now, what you do is you grow animals, by definition, very far from where people are. So there's inefficiencies. Obviously, there's incredible use of resources. There's very long supply chains. And then there's a waste along every step of that supply chain. But if you can shorten these supply chains and you can produce these animal products in a microbrewery environment, or eventually in restaurants, or eventually, who knows, perhaps decade plus from now, have your own right next to your bread maker or your mystery stealth device.
Just use your old hot water heater.
You can have your brewer in your kitchen, your meat brewer. It's a totally different distribution model as well. So production and distribution can co-evolve.
Yeah. And so I'm curious from the panel's perspective, I think there's a lot of optimism, a lot of excitement. Is there any fear of backlash to any of these new ideas, rational or irrational? And what are some of the big myths out there that scare you if they don't get knocked down?
Yeah. Well, having lived through the 90s, and seeing the first introduction of biotechnology, and technology is generally viewed as something that can be positive, and in foods it can be both improving the sustainability as well as the healthiness of the foods. However, there is a sizable minority of the population, and it does differ worldwide, that views biotechnology in foods as fundamentally unhealthy. So, and there are a lot of reasons for that, but to have these technologies adopted, fundamentally we've got to do not only a much better job at communicating the benefits, but showing real examples of products that are in fact either more creative, interesting flavor that sparks our imagination, or something that is tastes great and is much healthier that make people so that they don't have to make a trade-off. So it's providing real concrete examples of biotech in foods that have benefits for the consumer and are recognizable, not just for the farmers, and then being very transparent and accurate in the labeling and communication about that. I mean, I think those have been the two big issues, and those aren't going to be solved overnight, but we have to start the trend line to prepare an area for better acceptance. But
it sounds like the key is to make it not be something that's happening in the back room somewhere where you're saying don't look. It's to be public about it and say here's why we're excited.
Well, to Jim's point, it's kind of interesting. We all sort of look to the political right as being Luddites when it comes to things like climate change. But if you look at GMO, it's the political left that are the Luddites on GMO. Now, mind you, I'm one of them. I mean, I like to eat things that are healthy, natural, etc. But if you talk to scientists, they're as skewed in favor of GMO as they are skewed on man-made, problems in the environment. So, we do need to address those issues, and I think we need to address those issues through education, but also through labeling.
Absolutely.
I'm actually surprised when I talk to audiences about how open they are to the idea of cultured meat. But the key absolutely is that you have to be very transparent about it. And to Reshma's point, you have to put it in the context of our long history of cultured foods and of fermentation. But I think the reason why we spend a lot of time talking about what we're doing in our food program is, unlike other areas of technology innovation where it's in your interest to be stealth and then to spring it on the consumer because that gives you great advantage, I think in the area of food, you cannot talk too much about it. I mean, really, we have a materials program. That's what we're commercializing first. There's a lot of great research and innovation there. That's our emphasis. But I spend most of my time talking about food because by the time it comes to market, I want actually consumers to be bored by it. I don't want them to focus on the technology of it. I want them to focus on the fact that it's delicious, the fact that it's a product, and they shouldn't think. They should think, oh, I've heard about this a long time ago.
Nobody likes secrets in their food, and even the top chefs, the top restaurants publish their cookbooks that give all their recipes away. Right? There should be no secrets. So we're keeping you from lunch. So just want to give a chance for one or two questions in case there are any burning questions from folks in the audience. We'll start here and then we'll go to the middle.
Okay, Gary Carr from WCG Communications Firm. First of all, I want to say that as a lover of puns, this panel has been wonderful. We've had the subject being ripe, things soup to nuts. I wrote some of them down. They were so wonderful. I'm going to steal them later. These are meaty problems. So just, terrific. So if you like puns, just have a food panel all the time. The real follow-up question actually is, a lot of this discussion for an average person might seem like the most ultimate first world problem, right? Urban, wealthy folks talking about new ways to ferment meat and introduce fermentation, which as a lover of wine, I'm for too. But for, your average person living in maybe in Modesto or somewhere in Nairobi, it's like, really, if they could talk to you, I just got to figure out how to get this cow to plow this field. That's what I got to do. So how do you merge that from being very elite problem that everybody's concerned about here to a average consumer? I think I want to try that.
Well, one thing I'll point to is when we look at developing new sources of food, there's actually a nice way to merge this with economic development needs. So one of the things we've actually explored with is, as we evolve, for example, algal technologies, is essentially the way to make this an opportunity, an economic opportunity for a small landowner. Most farms in the world are 1 to 2 hectares. So if we can generate something that produces, triple the value of the current crop, then there's essentially we are not only providing them addressing food security issues at a real fundamental level, but it's also creating an economic opportunity. So you're absolutely right in your perceptions that we have a lot of choices about what we eat, but I think there's a way for some of these technologies to actually be positive contributors beyond the first world.
Yeah, I'm absolutely convinced that if you do a good job of creating a delicious product aimed at, let's say, first world, sophisticated urban consumers, ultimately that'll benefit the entire world. I mean, it's very important that when you innovate in food, you don't segment your market and think, I'm going to come up with something that's going to just feed the bottom of the pyramid and it's going to be good enough for them. You have to come up with a food which appeals to everybody. And if you want to be successful, it has to be good for the very best and most discriminating customers in the world. And if it's good enough for them, and you can ultimately make it scalable and affordable for everybody, then you can feed the planet. So that's our philosophy about going to market. I guess you could say it's a Tesla type approach. You have to create ultimately products that are very desirable, and then you can ultimately democratize them.
Yeah, I mean, I think, one of the interesting things about biology is that it's the ultimate in distributed manufacturing, right? And this is not about, high-end technology that we're going to just bring to the world and we're going to bestow upon them. I think there's a little bit of a paternalistic attitude there that I think we need to be careful of. An underlying theme of kind of what we're all talking about here is how do we make the design of biology easier, more ubiquitous, replace technology with biology? Like, how do we go back to our roots in biology, right? And I think, one of the reasons why we got into to thinking about cultured ingredients is we were looking for places where our ability to engineer the biology could have an impact. And cultured foods and cultured products are just the first place. If we actually can design biology, there's so many more opportunities beyond that. Can we design microbes that replace fertilizers to make our crops grow better? Can we design probiotics that can treat gastrointestinal disease? I think there's many more opportunities that are just lying in the wings to be realized if we can actually get good at designing the biology. And I think it's a little presumptuous to think that the first world is going to have a monopoly on thinking about designing biology. I think biology is ubiquitous, and the tools are becoming more and more available. That it's a technology that belongs to everyone.
Yeah, let me make one comment from a systems standpoint. What I really love about the agri-tech business, food tech business as part of the agri-tech business, is it's one closed system. If I take pain off in the developed world or North America, I create opportunity elsewhere. And it is the information, the distribution network. Remember, when you're looking at farmers growing in poor countries in Latin America, they're growing crops for us. They're not growing for themselves. And so if we can begin to change that mix in ways that allow them to address their own populations differently, by taking some of that pressure off in our own population, by giving them information and data that helps them from a supply chain standpoint on a global basis, gives them best practices for operating in small farms, which I think is one of the things that is, again, I think as Jim points out, very poignant need as we take a look at the world outside of North America. Then we are actually addressing a global issue of poor and rich. Because it is a closed system.
So we'll just take one last question, and we'll get some quick answers.
I'm curious if you have any unique regulatory hurdles and what your strategies were to overcome them with these products. And also, if you take it out to distributed manufacturing, how does that play out? So with the consumer growing meat in their kitchen, for example.
Andres, do you want to start with how do you actually sell these foods?
We are just at the beginning of understanding the regulatory path on the food program. On the materials program, thank goodness, the regulatory path is very simple, and that's why we're commercializing that first. That's one of the reasons.
Is the USDA going to put their stamp on your meat?
So it's interesting. Our intuition right now is that it's much more FDA-led. USDA regulates when animals are involved, but since here animals are only involved at the donating cells, after that, It's not really a USDA regulated process. However, our aspiration, and we believe we have a strong case that we can make on this, we're now working with regulatory consultants to validate this, is that there is a strong case to be made that this could be grass. Because at the end of the day, the cells that we're working with are natural cells, and they're grown in natural ingredients. So if you have natural cells grown in natural ingredients and you make a product through that process, natural plus natural or grass plus grass should equal grass. So again, this is a great theory. We'll see if this flies. But if we can get grass consideration for our process, that would be the easiest thing. If not, then we do have to go through a regulatory process with FDA.
Is algae any easier?
Yeah. So we start with organisms or cell lines that have had some history of use, either in certain human foods or actually as feed or aquaculture ingredients. So starting with a safe background has been important. One of the nice things now, we can use the knowledge of genomics, and we can essentially scan that genome for anything that could be potentially problematic, either in terms of a toxin compound, or even in the case of proteins, we actually look for absence of known allergens. And that's one of the beauties of having the power of genomics now, so that we come armed with a strong dossier. But there is a good, clear, well-established path in most countries, and starting with a safe organism and that we have a lot of knowledge helps in the process.
Do you have to do human trials, or do you have to have somebody taste it or eat it?
Well, before I guarantee you, we're doing a lot of tasting. So, before we're going to put that out, but the answer is it depends. For some products, we likely will have to do or will do some additional testing. It's really mostly animal testing, and for others, we can actually make the argument that it's essentially equivalent to certain things that are already out there, and that's an even shorter path.
So I'm hearing a lot of grumbling stomachs, so I think we'll probably close this panel and move on to lunch. And so I don't know, David, did you want to close, or should we just release everybody?
I got to say a few things.
So we'll have David say a couple of things. But thank you, everybody, for your attention and your close listening for the fun.
Yeah. Really good. Nice job. And I have a vegan friend in New York, and when I was telling him about Modern Meadow, he was like, I would eat that. So, the demand is there. I think it really is. So, okay, we're going to go to lunch. Sorry for the slight delay there. It's in the Grand Hall, so you go out and go past